So 3.4, we want to look at limit at the infinity. So far, what we did is we talk about limit as x approaches to 1, limit as x approaches to 2 from the left-hand side or from the right-hand side. But what we are interested in now is like, what if as x go into infinity or when x approaches to negative infinity, right? What does that means for us in terms of calculus? So if you look at, this function that I'm giving to you right here, right? And you can see that clearly this is a rational function. So I have a vertical asymptotes and I have a horizontal asymptotes right there. So what we learned before is like, on a vertical asymptotes, right? As x approaches to 1, that does not exist because when we look at from the positive sides, it's going to negative infinity. And then when you look at from the negative sides, approaching from negative side, that's going to positive infinity. So the directions of the limit approaching at 1 from left-hand side, right-hand side is different. So therefore, the limit does not exist, right? And this is the directions. It's not a limit. It doesn't mean that the limit exists. So now, what happens if x is going to positive infinity or x is going to negative infinity? That's what we want to look at it. So if you look at from this graph, I can sort of intuitively talk about like, this is something that, we have learned it before in pre-calc, sort of pointed out. So as x approaches to positive infinity, means that you're getting larger and larger, larger x. As you can see, this graph is basically approaching to what this horizontal asymptotes. Okay. And also, as x approaches to negative infinity, going to these directions, and the graph on the top, right, is approaching to this horizontal asymptote from the top as we move on. So now what we can do is we can basically like, define, okay, this way. If, right, a function f is defined on some interval a to infinity, then if limit as x approaches to infinity of f of x exists, that basically means the value of f is arbitrarily close to L. See, notice that when the idea of a limit is what you will never reach to it, but you know that it's going to that directions and it getting closer and closer, right? Which means what? Closer to this limit L when x is sufficiently large or x is sufficiently what? Sufficiently small, right? So before I move any further, is there any? So what we're gonna, connect is basically using this limit as x approaches to infinity of the function, right, equal to L, that idea to something that we already know in the past. So if the limits as x approaches to infinity of the function has a limit, or if x approaches to negative infinity of the functions has a limit, then we call those limits as a horizontal asymptotes. Okay, horizontal asymptotes. So that's how we're gonna be like approach it in the idea of limits with something that we learned in the past. So the horizontal asymptotes, we know that is what? Y equal to a number. That's the equation. And to find out those limit to infinity, we really need to, know this theorem. The theorem said that if n is greater than 0, is a rational number, okay, then limit as x approaches to infinity of 1 over x to the n power is equal to 0. Now think about it. If n is a rational number greater than 0, right, and as this number x getting bigger and bigger, and if you raise the power, then the denominator will be even larger number. 1 divided by a very large number, that is what? Pretty close to 0. Right? And then we know we call that as what? Approaching to the limit of what? 0. So this is a useful theorem that we're going to use in our computations later on in the examples. Right? Any questions before I move on to the examples? So example 1, we want to evaluate limit as x approaches to infinity of 3x plus 5 over 6x minus 1. So the idea is we want to use the theorem. So therefore, there's a couple ways to do this. Okay? One is using the factoring idea, and the other one is multiplying by 1 over a certain degree of x. So first, I'm going to show you the factoring idea, and another example I will show you how to multiply things. So in this case, limit as x approaches to infinity, I can factor x out in the numerator. So that will become 3 plus 5 over x. And then in the denominator, when I factor out x, that will become 6 plus 6 minus 8 over x. So the x reduce it, so that will give me limit as x approaches to infinity of 3 plus 5 over x over 6 minus 8 over x. And when I take the limits, since the limit on the numerator and denominator exists, I can use the laws of limit to take the limit of the numerator and the limit of the denominator. And when I take the limit of the numerator and then the denominator, then I can use sum and difference property to rewrite it into this format. So limit as x approaches to infinity of 3 plus limit as x approaches to infinity of 5 over x, and all over limit as x approaches to infinity of 6 minus limit as x approaches to infinity of 8 over x. So this gives us 3 plus 0, because this portion of the limit becomes 0 by the theorems, and all over 6 minus 0, which my final answer is 1/2. So once again, what I want to point out is you always need to think about the laws of limits correctly, right? Because you can only write it down like from this second step to third step if the limits of the numerator functions and denominator functions are defined, right? Exist. Now, is there any question? So another way that we can approach is like, instead of factoring, we can basically use the multiplying by, 1 over a certain power of x. So in this problem, if we look at this limit as x approaches to negative infinity, and what I'm going to do is I'm going to try to multiply the numerator and denominator by a certain power, okay? And usually what we do is we try to multiply by the bigger powers of the denominator, okay? So I'm multiplying by this, 1 over x to the third power. So when I do that, what's happened is I will get this. On the numerator, it will become 4 over x. In the denominator, the second term, I will get 1 over x squared. And in the denominator, this will be 2 and minus 5 over x to the third power. Now, using the laws of limits, right, I can basically talk about limit as x approaches to negative infinity of 4 over x minus limit as x approaches to negative infinity of 1 over x squared, and limit as x approaches to negative infinity of 2 minus limit as x approaches to negative infinity of 5 over x to the third. So this gives us 0 minus 0 over 2 minus 0, which will give me the limit is 0. And that's what we got. So that's another way to approach it. So let's take a look at on this example, right? 3 minus 2x to the fourth power over x plus 1. So as x approaches to infinity, what is my limits going to be in this case? So, this kind of situations, like, if you use the technique that I mentioned earlier, what's going to happen is like, you're going to get something, but like, not really see what's going to going on, right? So one thing to make it clear is like, I'm going to show you this way so that you can see what's going to happen on this case. First, notice that the degree of the numerator is bigger than the degree of the denominator. So what I'm going to do is I'm going to try to divide it, right? So I'm going to use synthetic divisions to divide it. So to rewrite this limits, this rational expressions. So -2, and then I don't have the third power, I don't have the second power, I don't have the first power, and I have a constant 3. And divided by linear right? That's a good thing. That's why I'm doing this linear. Otherwise, you're going to have to use the long division. Since this is a linear divisor, so I can divide by -1. So using the synthetic division, so it'll be -2, you multiply them, and you add the row 1 and row 2, and you multiply with row 3 again. So -2, add them up, multiply again, right? And then add them up and multiply again, and which gives me -1 right here, right? The remainder. Oh, not -1, 1, the remainder. So that basically tells me I'm starting with x to the fourth power because of I'm divided by the linear divisor, so it'll be x to the third power. So what happened is I can rewrite this into like this, limit as x approaches to infinity of this. When I divide it, that will become -2x to the third power plus 2x squared minus 2x plus 2 and plus, that's the remainder right here. So therefore, it'll be 1 over x plus 1. Okay. So now what I can do is I can look at my limits because the limit of a polynomial always exists. So I can say that limit as x approaches to infinity of -2x to the third plus 2x to the second minus 2x plus 2 plus, and since this is a limit, this is like in the denominator, x has exponent of a rational, so I can say that limit as x approaches to infinity of 1 over x plus 1. So from here, you can basically see that this portion right here, the limit is 0. And now you need to deal with this. And this basically, like, you can easily think about the behavior, the end behavior of the polynomial functions, and then basically, write it down, right? Because you don't really need to test it. So this is a third degree polynomial. And with the leading coefficient is negative, so my end behavior is going to be going like this on the as x is moving around. So therefore, as x approaches to positive infinity, my function value will be what? Going to negative infinity. So therefore, I can see that this limit is going to negative infinity. So therefore, negative infinity plus 0, we are going to what? Negative infinity directions. So this, okay, so this is basically what? Going to negative infinity. Any questions before I move any further from here? So, the way that I write it down right here, it has a problem because there is a violations on violating the laws of limit from this step to this step, because the limit law tells us you can only write the limit as a sum only if each limit this exists. But in this case, we can see that this is not, right? So therefore, but however, I can sort of the idea is this portions in the functions 1 over x plus 1, that's not really going to affect the end behavior of this polynomial functions, right? So therefore, this will eventually become 0, and then you can just talk about the end behavior. So technically from here, right, writing, it should have been, you can basically say that from here, according to the end behavior, because this will become like, you can, as go to infinity, this portion can be ignored. So you can basically just think about the end behavior of this polynomial, which is basically going to be what? Going to negative infinity. And that is the proper way of thinking. And this is the type of problem and then the reason why I like to use the method of factoring more than multiplying by 1 over x to the some power. Right? So let's take a look at on this problem. So for this problem, first thing that we might be like, get dragged by effect from the limits manipulations in the past is you might probably multiply by conjugates and then continue from there on. But however, the limit is as x approaches to infinity, so not at particular points. So what we want to do is we want to use the theorem that we talked about earlier. So take a look at how I'm going to approach this, the same idea, using the same techniques from the first few examples. So on the numerator, I'm going to factor out x squared inside the radical. So this will become 1 plus 2 over x squared. And then in the denominator, I'm going to factor out x. So it will become 3 minus 6 over x. So continue looking at this. That will be limit as x approaches to infinity of, this will be square root of x squared times with square root of 1 plus 2 over x squared. And then that will be x, 3 minus 6 over x in the denominator. Now here's the part, okay? A lot of times we might be thinking right away that, okay, for as x approaches to infinity, this is not a problem. You might be right away thinking about, oh, square root of x squared is basically what? X times the square root of 1 plus 2 over x squared, and x times 3 minus 6 over x. Okay, so you might not feel anything that, you know, and then you carelessly try think about this part if you don't pay attention enough, right? You're gonna carelessly think about like that way. What you really need to think about is this portions, which is something that we already know from the past. Square root of x squared, that is not x. That is, from the definition, from algebra, is absolute value of x. Okay, so if you think about square root of x squared is equal to x, you are already, like, you know, making a mistake on the way that you think about this expression. Now, why does it become x? Now, a square root of x squared is equal to absolute value of x. Now, the x value that we are approaching to is positive infinity. So I have to think about this absolute value as x if it is x is greater than 0, negative x if x is less than 0. Because of the limit that we are approaching is x going to infinity, so therefore I'm choosing what? This x to replace right here. So is there any questions before I move any further? So now what I can do is I can basically reduce the x, right? And that will give me square root of 1 plus 2 over x squared, and then 3 minus 6 over x. Now the numerator, right, limit will exist, and the denominator limit will exist. So therefore I can use the law of limits to rewrite it as square root of limit as x approaches to infinity of 1 plus limit as x approaches to infinity of 2 over x squared, all over limit as x approaches to infinity of 3 minus limit as x approaches to infinity of 6 over x, and which will give us, right, which will give us from here, which will give us square root of 1 plus 0 all over 3 minus 0, which is going to be 1/3. And that is my answer on this. So the only difference on, you know, the example E and example F is example F, your x is approaching to negative infinity. So if we approach the same way that we did before, right? On the first step, you factor out x squared, and then after that, you factor out square root of x squared. And now the difference is from this second step to the third step. So before is because of approaching to positive infinity, you know, square root of x squared will be replaced by what? X, because it's going to positive infinity. But however, at this time, x is approaching to negative infinity, so you cannot use this anymore, right? When x is approaching to negative infinity, we're going to be like using what? This formula to represent square root of x squared. So that's a big difference right here. So therefore, this will become negative x. And when you reduce it, you have an extra negative factor right there. And that negative factor will be moving along all the way to the front. And then my final answer will become negative 1 over 3. And that is the difference between example E and example F. And you really need to, you know, think about carefully on the expression square root of x squared. So you should try yourself on example G, okay? And the hint that I'm gonna give it to you is rationalize the numerator. And once after you rationalize it, you can basically approach the same way that you did in example E and example F. So now let's take a look at on example H, when the limit as x approaches to infinity of square root of x and then sine of 1 over x. So this type of problem, is basically, we cannot do much because one is a science functions involved. Like, you don't want to, you cannot substitute it like in infinity either, because this limit does not exist. So does it really go to infinity? That we don't know, right? Direct substitution is not applicable. So we're going to try to manipulate and then put it into a form that we know from the past, right? And then see whether that actually going to help us or not. So let's take a look at on this part, right? So first step, what I will do is I will try to rewrite limit as x approaches to infinity, rationalizing the square root of x. So that will give me x, right? And then sine of 1 over x over square root of x. See, I basically multiply top and bottom by square root of x. So that will basically help me to get this. So let me give you a write down part so that you can see it. So times with square root of x over square root of x. So square root of x and this x become, square root of x become x, right? And why do I do that? Because I want to try to rewrite it into something that we learned before, right? So next step is limit as x approaches to infinity. I'm going to try to put it into a certain format, right? See that will work or not. So let's try to take a look at this. Oh, okay. Let's do this. So before we write in it, let me replace the variable. Okay. So this is the important part. I'm gonna let t be equal to 1 over x. This argument right here. So that basically tells me, okay, x will be equal to 1 over t. Are we all okay with this so far? Now, after you replace a variable like this, right? Substituting a variable represented by another, then what I can do is I'm going to be changing the limits also in terms of variable t. So what happened is we know that t is equal to 1 over x. So what happened in this case is, t will be approaching to 0 from the positive side as x approaches to infinity. Because think about it, as x go to infinity, right? 1 over a very large number, that will become what? Getting closer and closer to 0. But closer and closer to 0 such in a way that is from the top, not from the bottom, because if as x approaches to negative infinity, that will become what? 1 over a very large negative number, which will be, you're going to be getting a very, very tiny a negative number, but it's very close to 0. So you are basically approaching to the value 0 from the negative side. So that is very important, that part you need to understand, right here. So now, after we get this, what we're going to do is we're going to rewrite our limits, right, with a different variable. So now x will be replaced by 1 over t, and then sine of, instead of 1 over x is replacing with t, and all over in the denominator will be square root of 1 over t. And now for the limit part, instead of a limit as x approaches to infinity, now this time the limit will be approaching to t goes to 0 from the positive side. Right? So that is basically change in the limits and a variable, right? The limits of the variable. So now what allow us to do from this point on is basically this. So I can see that this will be limit as t approaches to 0 from the positive side, right? Of this will be, let me write it this way. This will be sine t over t on the top. And this is basically 1 over square root of t. So when you simplify and then multiply by reciprocal, this will become the limit as t approaches to 0 from the positive side of sine t over t, and times with square root of t. Now, we know that this limit, the first factor exists, and that the second factor also exists as t approaches to 0. See that? It has to be very consistent because the square root of t, t has to be is approaching to 0 from the right-hand side, because this square root of t doesn't have a, the graph on the left-hand side. So you cannot approach it from 0 from the left. So now, finally, this will give us, limit as t approaches to 0 from the right-hand side, sine of t over t times with limit as t approaches to 0 from the right-hand side, square root of t. This limit is 1. This limit is square root of 0, which is going to be what? 0. And this will be my final answer for this. So the main idea of this this example is learning these techniques, changing the variable, right? And then when you change a variable, the limit has to consider differently also. For example, I and j, I is just basically straightforward limit as x approaches to infinity of x to the 4th power. You don't need to show any works at this point. Thinking about the end behavior of even power on polynomial, that is basically either go like this or either go like this. Since this is a leading coefficient is a positive, so we are ending up in this situations right here. So as x approaches to infinity, the function value is going also infinity. So therefore, it will be what? Positive infinity. And for j part, limit as x approaches to infinity of x squared minus x to the 4th power. Right here, a lot of the misconception is, a lot of mistake is like simply saying that, oh, I'm gonna make it, by looking at this part, there's a even exponents, and this is also even exponents. So we're gonna talk about infinity minus infinity, right? That's 0. No, that's not wrong, because the limit is approaching, for each part x squared and x to the 4th differently. So we don't know these infinities are the same number. So the way to present it, write it down answer for this is basically think about this different idea. As limit as x approaches to infinity, factor it out, which is x squared, 1 minus x to the 2nd power. Okay. So from here, then you can sort of think about, this limit is infinity and this limit is a negative infinity, right? Times with negative infinity. And basically that will help us to get negative infinity at the end, because a very large number times with a very large negative number, that will give me even a larger negative value, right? So this is how you need to show your work, although the limit does not exist. So we can basically think about the idea of like, end behavior and then talk about each part, right? So that's why I never write it down as like, limit as x approaches to infinity of x squared times limit as x approaches to infinity of 1 minus x squared. I never split it out because that will violate the laws of the limits that we learned before. So this will conclude this sections.